Welcome back to video number 2. This one's going to be about speciation. So this is how species turn into new species. For a species to separate out and you to have two distinct species, of course we need to have reproductive isolation. We're going to talk about two different ways that this can happen, allopatric and sympatric. First off, allopatric speciation, this is where you get a physical barrier that is going to be between the two different, the population. So I have one population and something like a canyon or a river goes through them and separates it out into two separate populations. Then they're going to be subjected to different selective pressures, and it's going to cause them to evolve separately. And if reintroduced to each other, they will have evolved so differently that then they are now different species. Let's take a look at these mice here. We have our original population of white mice. There's a little creek next to them, but it changes path and it splits them off. So now I have two separate populations of mice. They're going to be subjected to selective pressures. On one side of the river, they have a selective pressure that's pushing them towards being brown. On the other side, they're staying the same. And if time passes and they've evolved enough, even if the river changes paths, and you see here in the last one, we end up with them being separated to where they're mixed back together. But now they're so different, they're reproductively isolated, so they are no longer the same species. This doesn't have to happen in the presence of a physical barrier. It can happen sympatrically, which means that they are in close proximity with each other. They are in the same area, but they have some form of selective pressure that's going to push them in opposite directions. So again, if we take a look at our little white mice, we're going to have some type of environmental pressure that's going to push it's going to be like the disruptive evolution where it's going to push to the separate side. So we had the white mice and the tan are going to push towards brown. And even though they are in the same habitat, eventually, since there's more advantage to be the brown and more advantage to be the white and no advantage to be the tan, they're going to become reproductively isolated, therefore becoming a new species. Okay, let's talk about the different patterns of evolution. We have adaptive radiation, coevolution, and convergent evolution. Adaptive radiation, this is where you have one common ancestor and lots of different species are going to come out of it. So they're going to adapt and it will radiate out. So you see here we have the fish. They eat lots of different types of things. They look very different, but they all came from a common ancestor. Coevolution will be when the two organisms, they're so intermingled with each other and so close to each other that they're going to influence the other one's evolution. So such as when you have a parasite or a mutualistic relationship or a predator-prey relationship, as one evolves, the other will evolve with it. So if you have the gazelles and the lion, as the gazelle gets faster and faster, so will the lion, because if the lion does not, it will not be able to eat, therefore it will not be able to survive. Okay, convergent evolution. This is where you have two unrelated species that are going to have similar traits. They're going to evolve these similar traits because they have similar selective pressures. If you look at the flying squirrels and this phalanger, they both developed the gliding wings because they had selective pressure for that, but they don't have relation between each other. Okay, and last one, we have two different types of two ideas of the rate in which the speciation has. We have gradualism and we have punctuated equilibrium. Gradualism means that things happen very slowly. Punctuated equilibrium means that we had things happen in quick little bursts, quick little spurts. Okay, let's watch a video on that. Okay, whoops, go back, try and watch the video on this. There we go.
Believe it or not, evolution doesn't occur in just one way. It's not about making everything better all the time. Instead, there's plenty of evidence for cases where evolution and the creation of new species occurs through gradual and fairly constant changes. One pattern of evolution is when a new species is split off from its ancestors and both continue to change at similar rates. This is called gradualism. Another pattern of evolution is called punctuated equilibrium. This involves a short period of rapid change of a population, most likely after it becomes isolated. In this pattern, the population forms a new species, after which the process slows down and approaches stasis. As you can see, there's no single pattern of evolution. Instead, it's all about favoring organisms that breed and pass on their genes however they can.
Okay, I hope that clears that up for you guys. And we have now covered all of our essential questions and all of our vocabulary. Thank you for viewing, and I will see you guys in class.